Hello all. Today I'll talk about a case study on portfolio management. We look into the areas to focus and why we'll be using PCA to perform the case study and the steps which we take to perform the case study. We'll be mainly focusing on the pre-processing techniques and why we are using PCA, and also about the explain variance plot, which is very important to choose the number of components. This is just a overlook of the companies which our portfolios will contain. We'll be using about 30 companies in our portfolio, and we can see about half of the companies which will be in our portfolio. Like for example, like companies like Apple, Microsoft, Walmart, and etc. We apply the first step is to do pre-processing on the data set. So we first standardize the data set. We basically standardize the returns to a mean 0 and variance 1 before applying PCA. Standardizing helps PCA to work effectively by giving each asset an equal weight and variance analysis. And also before standardizing, we also make sure to drop null values. So the explain variance plot is it actually helps us to decide the number of components to use. We are looking for the fewest components that together explain at least 80% of the total variance in returns. We find the minimum number of components that explains the 80% of the variance in the whole portfolio. Visualizing this plot makes the task easier. It will be clear why we use explain variance plot as we see the code. So basically, why do we use PCA? So we use PCA because uh, it provides us with a number of advantages. This is just two of many advantages. Uh, it helps in dimensionality reduction. In financial markets, we deal with many assets and consequently a larger data set of returns. PCA reduces the complexity by identifying a smaller set of principal components that capture the maximum variance in the data. For instance, in a 30 stock portfolio, instead of analyzing 30 individual stocks, PCA allows us to focus on a few components that explain most of the variability, simplifying analysis and visualization. And the next benefit PCA provides is risk decomposition. PCA helps identify underlying risk factors that influence a portfolio. Each principal component represents a different direction of variance in the data, which can often correspond to risk factors such as sector exposure, market conditions, or macroeconomic trends. This is valuable for investors aiming to understand the specific sources of risk in the portfolio. These are the steps which will take to perform the case study on portfolio management. We first import the libraries, then download the data and perform PCA on the returns, and then we select the number of principal components. As I said, we use the explain variance plot to select the number of principal components, and then we construct the eigen portfolios. We then calculate portfolio returns and risk. After that, we perform portfolio allocation, and then we visualize the portfolio weights, and at last we evaluate the performance with cumulative returns. We'll look into the video now. Thank you. I'll walk you through a practical case study on portfolio management using eigen portfolios. Eigen portfolios are created using principal component analysis or PCA, which helps us identify the primary factors driving risk and return in a portfolio. Let's dive into how to build and analyze an eigen portfolio using Python. At first, we'll import the libraries and download data. First, we need to import the essential libraries. Here, I'm using NumPy and Pandas for data manipulation, and YFinance for retrieving financial data, and Matplotlib for visualization, and PCA from SQL and decomposition to perform PCA. And then now we'll download the daily adjusted closing price for the 30 companies in the Dow Jones Industrial Average, that is the DJIA index, which we'll use as our data set for portfolio analysis. We use Yahoo Finance to download this data from 2018 to 2023, focusing on the adjusted closing prices. Once we have the prices, we'll calculate the daily returns. Now we'll perform PCA on the returns. Here we standardize the uh, returns to have mean 0 and variance 1 before applying PCA. Standardizing helps PCA to work effectively by giving each asset an equal weight in variance analysis. Then we initialize and fit the PCA model to our standardized returns. This is an explained variance plot. The explained variance plot helps us decide the number of components to use. We're looking at the fewest components that together explain at least 80% of the total variance in returns. I plot the cumulative variance here to make this choice more visual. Selecting the number of principal components. Now we find the minimum number of components that explain 80% of the variance. In this case, n components is the point at which cumulative variance reaches 0.8 or higher. Now we construct the eigen portfolios. Once we have selected the number of principal components, we refit the PCA model to extract these eigen portfolios. Each component corresponds to a portfolio that represents one direction of risk in the data. Now we calculate the portfolio risk and returns. We can calculate the annualized returns and risks for each eigen portfolios, which lets us see how each principal component contributes to overall portfolio performance. In this, we can see how each portfolio component contributes to the overall portfolio performance. I'm just initializing the mean returns and the covariance matrix in this cell. Now we move on to the portfolio allocation. So here, now we can allocate weights to create a new portfolio based on these eigen portfolios, ensuring our weights sum to 1. Now we move on to visualizing the portfolio weights. Now we can finally visualize the weights in our portfolio to see the distribution across assets. This plot highlights which stocks have larger allocations in our final eigen portfolio. So from this plot, we can actually see which portfolios have the highest allocations in our final eigen portfolio. Now the last and final step, we evaluate our performance with cumulative returns. To conclude, let's visualize the cumulative returns over time. This shows how our portfolio would have grown if we had invested according to the eigen portfolio allocations. So in conclusion, the eigen portfolios offer a powerful way to manage risk and return by leveraging PCA to uncover the main drivers of variance in our portfolio. This approach can give us unique insights and help in building well-diversified and risk-adjusted portfolios. Thank you.